Here we're going to look at question 73 from the IMAT 2012 paper. So in this question, we're told that when mercury is cooled to 4.2 Kelvin, it becomes a superconductor, which means that it has no resistance through it when electrical current flows. So the question asks us is, when a current does flow through it, which of the following effects will be present? Thermal, chemical, or magnetic? So if you'd like to have a go at answering this question yourself, then please pause the video now, otherwise we'll have a go at it together. Okay, so as we always do, let's work through these statements one at a time, beginning with thermal. So, basically, if thermal energy was being released in this sort of reaction where a current flows through the superconductor, then surely there's some energy being released from the system. So there's going to be some sort of power of our system. But we know that electrical power has the equation P equals I squared R. And since we know there's no resistance in a superconductor, in this mercury, there's going to be no energy dissipated at all. There is no power. So this means there's going to be no heat, no thermal effects. So this statement has to be false, or this isn't going to occur. Next, let's look at chemical. Now, a chemical effect would sort of suggest that something's actually happening to the chemical makeup of our mercury, of our superconductor. But when it's cooled down, it's not as though some sort of magical effect happens. It just has no resistance. So there's nothing actually happening to the mercury. There's no sort of chemical reaction going on. There's only mercury in this. It's not like it could react with another chemical. So this, again, must just be false. There's nothing really which could be suggested to be happening in this case. Third and finally, let's look at the suggestion of magnetic effects. So when we have a current flowing through a wire or through a superconductor or something similar, then this will actually produce a magnetic effect, which is sort of governed by this right-hand grip rule, which you might have learned about, where we can deduce the direction of the magnetic field using this rule. This doesn't matter that there's no resistance at all. Since there is a current, it's still going to produce a magnetic field. So what this means is that, yes, there is going to be a magnetic effect present in the superconductor. And now with the first two statements being false and our final one being true, then we know this is going to correspond to a final answer of D given in the question.